This lesson we are going to get into a new big chapter about the equation of a circle. And before we get into that, we need to cover some basic concepts about circles and some knowledge from other areas. And the first thing is, how do you find the coordinates of the midpoints of AB in a coordinate system? So given you 2 points A, 1, 1, and B, 3, 5. So how do you find the midpoint of AB? So let me just connect AB together, and its midpoint will be here, C. And how do I find the coordinate of it? So at the very beginning, you can see that since C is a midpoint, there is a similarity relationship with the triangles, right? When we're making them up as a triangle, there is a similarity between triangle ADC and AFB. For A, the horizontal length is 1. Horizontal length is 1, and for B, it's 3, and I will record it as x2. So if we drop perpendicular to the y-axis, then the horizontal distance for C would be x1 plus x2 over 2 based on similarity. And similarly, the vertical distance to the x-axis is x1, is y1, and for B is y2. And based on similarity, so this length can be depicted by y1 plus y2 over 2. So the coordinates of midpoint C are half the sum of horizontal coordinates and half the sum of vertical coordinates. So it's x1 plus x2 over 2 and y1 plus y2 over 2. And let's just check for it. So we just use geometry to prove the midpoint formula for point A and point B. So the coordinates of C is, let's just plug x1 and x2 the value inside. So it will be 2 over 1 plus 3, which is 2. And the y coordinate is 1 plus 5 over 2, which is 3. And now let's get into a practical example. So suppose I have given you a circle. Well, actually you know nothing about the circle, but it's a circle. And I have told you that AB is the diameter of the circle. So how to find its center? Well, it's quite easy because AB is the diameter, so its center will be the midpoint of AB. And that's the reason why we should learn the midpoint formula. And how do I find the center? Well, suppose I have given you the point of A and B. So the midpoint of the circle would be 2, 3, just like we did before of the midpoint formula. x1 plus x2 over 2 and y1 plus y2 over 2. And this is called the midpoint formula. And let's take a look at another problem. So I have given you a circle again, but this time it's different. I know its diameter, and I know the point of A, which is 5, 3, and I also know its center, which is 4, 1. So how do I find another point of the circle? So here you see, we can set the coordinates of B as x1, x1, and y1. So the coordinates of C must satisfy 5 plus x1 over 2, which is 4, and 3 plus y1 over 2, which is 1. Because C is the coordinates of AB, so they must have a relationship between the coordinates. And after solving that, we will get the value of x1 is actually 3, and the value of y1 is -1. So that's how we solve it. Now let's talk about perpendicular lines. If two lines are perpendicular in a coordinate system that we learned before, the multiplication of their slopes, m1 times y2, must be -1. So where do we use the perpendicular relationship in circles? For instance, if you draw a circle and take any diameter, if you draw a circle from any diameter, lines from the endpoints to any point on the circle often involve perpendicular relationships. C giving you a point C. Here you can see a perpendicular relationship, or even let's say point F is also perpendicular, or even the point E is also perpendicular. It's a property of the circle. When you connect the other points with the diameter on the circle, you will get a perpendicular triangle. And let's just continue with an example. Suppose we have the same circle equation from before. Draw the circle. And A is -1, 4. So this is point A. And point B is at 5, 2. And we want to find the equation of the line passes through the center C, which is the midpoint AB. So first we can figure out its midpoint using the midpoint formula. The coordinate of C is x1 plus x2 over 2, y1 plus y2 over 2. And then we could find the center C, which is 2, 3. And then we could find, after finding the center, so what's the slope of, we could use delta y over delta x, which is y2 minus y1 over x2 minus x1, and it will be minus 1/3. Since L1 is perpendicular to AB, and their multiplication of slopes must be -1, so I will get this perpendicular line, its slope will be 3. And so knowing the slope is 3, I could get this straight line actually y equals 3x plus b. And in order to figure out the value of b, I can substitute c inside it. So it's 3 equals 3 times 2 plus b. The value of b would be -3. So this is how I find the equations of the yellow line, perpendicular to its diameter. So this section covers the midpoint, the relationship between slopes of perpendicular lines, and how to find an equation of a line. Once you master this very well, moving on to the circles will be way much easier. And then let's just look at part 2 of the textbook, coordinate geometry in the XY plane. And you should have some learning objectives. And after learning this chapter, you should be able to find the midpoint of the line segment and find the equation of a perpendicular bisector of a line segment, and know how to find the equation of a circle with different centers, radius, and positions. And you have to learn way much more of applications of circles. So this will be the end of it. And let's just dive into how to find the equations of a circle next chapter.